Thank you for joining us today. Before we begin, I would like to take a moment to say that we hope you and your teams and your families are all safe during these challenging times. Situations like these remind us how important stability, preparedness, and trusted partnerships truly are. And at Exquitech, we want you to know that we stand by your side and remain fully committed to supporting our customers and partners across the region. For those who may be joining us for the first time, Exquitech is a global technology consulting and managed services company specializing in cloud, data, and enterprise platforms. We operate with both local and global support capabilities, with several support hubs inside and outside the region. Our teams remain available 24/7 to ensure that our customers continue to receive the technical support, cloud operations management, and guidance they need whenever it is required. And for our current customers who are joining us today, we would like to thank you for your continued trust and partnership. We truly value the relationships we have built together. Over the past days, many organizations across the region have been thinking more carefully about operational continuity, infrastructure resilience, and how to ensure their cloud environments remain secure and available even in uncertain situations. As part of our commitment to supporting our customers, the Exquitech team recently shared a cloud infrastructure resilience advisory outlining recommended architectural measures and best practices for strengthening business continuity in the cloud. So today's session builds on that guidance. Our goal is to walk you through practical approaches to designing resilient Azure environments, including high availability architectures, backup and recovery strategies, and disaster recovery planning across regions. This session will focus on how organizations can leverage Azure capabilities to protect critical workloads and maintain service continuity. We are pleased to be joined today by our speakers, Carlos Silva Wilson from Microsoft, Elil Amil and Cassandra Atollah from Exquitech. They will guide us through Azure infrastructure resilience, high availability and disaster recovery architectures, backup and data protection strategies, and the key best practice organizations should consider when designing resilient cloud environment. Thank you again for taking the time to join us today, and let's get started. Floor is yours.
Thank you so much, Petra. I'll get us kicked off here. My name is Carlos Silva Wilson. I'm a partnerships lead here at Microsoft Middle East, leading key cloud channels business for our corporate segment across all of the industry verticals. And I have the pleasure of being here with you today and our premier partner, Exquitech, in such an important topic. Now, I want to kick us off by addressing a very important question, which is why disaster recovery matters and why now more than ever. I'm going to be a bit provocative on giving my view, as I believe uncertain times like this require more honesty than ever. And there is three hard truths that I want to bring to the discussion as we lay down some context. The first one is disruption is the new normal. Today, organizations face a volatile mix of geopolitical instability, cyber threats, and even physical risks to infrastructure. And you would know this. In recent years, Middle East companies have seen with everything from political conflicts to regulatory upheavals to extreme weather and surging cyber attacks. The second one is that these events underscored a very hard truth, which is downtime is no longer an IT problem. It's a business risk. It can cripple revenues, it can erode customer trust, and it can violate compliance. That's why a robust disaster recovery strategy and planning has become mission critical for the Middle East enterprises. The third hard truth that I want to bring to the discussion is that in an era of unprecedented uncertainty, you must ensure your business can survive outages, no matter their cost. And last but not least, IT resilience today needs to be a strategic priority, not an afterthought. That old mentality of our data center rarely fails is outdated. Reliance on cloud alone doesn't eliminate the need for DR. And this year has been a stark example of why redundancy and recovery plans are essentials. It's also proven that companies that invest in robust disaster recovery are better positioned to weather crises. So maintaining continuity and protecting their bottom line is a must. I want to also emphasize the importance of disaster recovery in the Middle East. Disaster recovery has always been about preparing for the worst, but in the Middle East, the worst is now more plausible than ever due to a mix of different things that I want to summarize as challenges. The first one is on the geopolitical side and security threats. We've seen political tensions and regional conflicts having direct IT impacts, and this is beyond the human and economic toll. Conflict can threaten physical infrastructure, and we've seen real incidents where data centers were damaged by attacks, causing cloud services outages. Organizations can no longer assume that a single data center or even a single cloud region is invulnerable. Disaster recovery, on the other side, ensures that you have isolated, secure copies of data and applications ready to go in an emergency. And modern DR strategies also integrate securities, i.e. immutable backups and air-gapped data copies, to make sure that your recovery data can be tampered with. The second point is on the infrastructure and power challenges. This region faces infrastructure stresses. We think about power grid instability, fiber cuts, or even extreme weather events. We have seen this recently as well. A localized disaster at one facility can't be allowed to take down your entire business, and that's why redundancy across separate facilities is more vital than ever. The last point is on the regulatory and customer expectations. Industries like government, finance, and energy in the UAE and Saudi have strict regulations for uptime and data protection. Additionally, customers now expect 24/7 service availability. Any downtime could mean losing critical transactions or eroding your brand reputation. In a competitive market, again, being offline is simply not an option. That's why having a strong disaster recovery plan and communicating to customers as needed can be a differentiator, proving your business is resilient under any circumstances. Now, let me switch gears a bit here because you might be asking yourself the question of how can Microsoft help? And this is where I want to introduce what we call ASR, the Azure Site Recovery. I want to go over key features for business continuity that are relevant for you today. To address the risks mentioned, organizations are tuning to cloud DR solutions. And ASR is a flagship services that helps keep your business running during outages. But what does ASR really do? In summary, it continuously replicates your workloads to a secondary environment. So when your primary environment goes down, it automatically fails over to the backup site. And then it helps you fail back seamlessly when things return to normal. This is what we call the hot standby approach, which minimizes downtime and data loss, delivering robust services continuity. But let me break this service down in 5 key main capabilities to make it easier for you to digest. The first one is on the continuous replication. ASR works by continuously copying your data and virtual machines to a recovery site in real time. Unlike periodic backups, ASR replication is ongoing, which means the secondary site is always up to date within seconds or very few minutes of the primary. This gives you a very, very important RPO, as we call it, recovery point objective. Essentially, minimal data loss occurs if a failure happens. For example, if your primary VMs goes down at 3 p.m., the replica VM in the DR side might have all the data up to 2:59, 50 seconds, losing at most a few seconds of recent transactions. The second feature to help you understand this service is the automated failover. When an outage strikes your primary site, ASR enables a rapid failover to the secondary site. This can be triggered manually with one click, but it can also be scripted or automated based on certain conditions of the health checks. The failover process is orchestrated for you, So ASR boots up the replicas in the correct order, connects network, and swaps over user access to the secondary side. The one important point on here that I want to make emphasis on is that human error is taken out of the equation, which is very critical during crisis. The result is a dramatically lower recovery time objective. The third point, the third feature of this service that I want to bring up to the discussion is the seamless failback. What do we mean with this? Disaster recovery isn't just about surviving the outage, right? It's also about returning to normal operations once once the primary site is restored. Azure Site Recovery handles this via failback process that is as seamless as the failover. Once your original data center or primary region is healthy again, ASR will synchronize any changes that occur on the secondary side back to the primary. So you can then just simply switch operations back to the primary environment with confidence that no data is lost and everything is consistent. This failback is also automated and tested. ASR performs health checks to ensure the primary is ready, replicates all new data, and then orchestrates the reversal. Again, the goal here is to resume normal operations without missing a bit of or overriding data. The fourth feature of this service is business continuity and orchestration. ASR is, again, a tool for ensuring business continuity. Beyond the replication and failover, it also provides a suite of orchestration features to make the DR reliable and routine. You can define your recovery plans that specify the order in which services come up. You can automate additional scripts to run at failover. And you can also perform non-disruptive test failovers to rehearse your DR strategy. For instance, you might script a recovery plan that brings up the database virtual machines first, then the replication, then the application servers, and then verifying the web services, etc. All automatically integrates with the Azure monitoring and alerts that I mentioned earlier, so you get full visibility into the replication health. You can also select to be notified on issues before they happen. The last point is on the features of this service is one that we have been getting a lot of questions recently, which is on the hybrid environments. And the good news here is that today a big advantage of ASR is that it covers various environments. It can replicate Azure VMs from one region to another, but it can also support on-premises workloads such as VMware or Hyper-V virtual machines and even physical servers replicating into Azure. For example, if you run your most critical apps in your data center in Dubai, you can use ASR to continuously replicate those VMs into an Azure region. In a disaster, you would have failover into Azure and keep operating. This flexibility means that Azure can be your central DR platform for both cloud and on-premises assets, simplifying, again, your overall continuity strategy. If we move to the next slide, please, Petra, I want to cover Azure regions and infrastructure resilience. Perfect. I want to also provide the audience with some context and guidelines around our regions and infrastructure resilience in support of your DR strategies. I think this is really important for this discussion. By following these guidelines and leveraging Azure's resilient infrastructure, you can architect a disaster recovery strategy that addresses both technical and business requirements. To explain this further, I want to make emphasis on a couple of things. The Middle East Azure regions today is built with world-class fault tolerance, from redundant everything inside data centers to spare capacity reserved for failures to multiple zones and regions. But it's up to each organization to use these tools wisely. At the end of the day, this depends on you. Building a solid disaster recovery plan requires an understanding of the infrastructure under the hood. And Microsoft Global Cloud is built for resilience with data centers or regions spread across the world. When we talk about Azure infrastructure resilience, we mean the multiple layers of protection Azure provides, from redundant hardware to multiple data centers in one region. The layer design is what makes services like ASR so effective. Let's move to the next slide, Petra, which is my last one as we conclude on the context and intro. I want to show you how Azure infrastructure helps keep your services available and how you can choose the right Azure regions for your disaster recovery strategy. I'll go over this high level because I know it's going to be covered a bit in the presentation, but I want to touch on 4 key aspects which which are super important when we think about Azure infrastructure. Number 1 is the regions and availability zones. These are key components of Azure resilient architecture. An Azure region is a set of data centers deployed within a specific geographic area connected by a low latency network. For example, in the Middle East, Azure currently has regions in the UAE and Qatar, with a new one in Saudi on the way. Each region, and this is really important, each region is designed to be isolated from failures in other regions. But within a region, Microsoft also adds resilience through availability zones. An availability zone, again, is essentially an independent data center within a region with its own power, cooling, and networking. There is an important caveat here to know, though. Azure regions that support availability zones have at least 3 separate zones. And I'll repeat that. Azure regions that support availability zones have at least 3 separate zones, so that even if one data center has an issue, the services in the other zones can keep running. For instance, Azure UAE North, Dubai, has 3 availability zones, meaning that your resources can be distributed across 3 separate physical facilities in Dubai. This greatly reduces the risk of a local outage taking down your application. And by architecting your solution across multiple availability zones, you can achieve high availability within the region. The second point is regions, pairs, and geo-redundancy. Azure also safeguards against a whole region going offline by using region pairs. Every Azure region is paired with another region, usually in the same geography, of course, to meet data residency requirements, but sufficiently far apart to avoid being affected by the same disaster. In a region pair, one region is a primary and the other one is secondary. And Azure designs updates and maintenance so that pair regions aren't taken down at the same time. And of course, some services automatically replicate data to the pair region. For example, Azure's UAE North region is paired with UAE Central, meaning that Azure replicates certain platform data between Dubai and Abu Dhabi for durability. As a customer, you can also take advantage of the region pairs. You might run production in one and you might use the pair for disaster recovery. The benefit, of course, is that data residency is respected. Both regions are in the same country or region, and network latency is often reasonable between pairs. One point here that is important is the geographic separation. You wouldn't want your primary and your backup in the exact same location. But of course, Azure's global network of 70 plus regions in over 30 countries also provide you with the flexibility to choose a DR site that fits your need. The third point is the location and capabilities. We've been investing heavily in the Middle East cloud infrastructure to support local resilience and compliance needs. Some key points I want to highlight here is that today all Middle East Azure regions providing country data residency, which is very crucial for compliance and local data laws, like the UAE national data legislation or Saudi's regulator like SAMA. In terms of resilience, I want to kind of get into a conclusion with some best practices and criteria for us to consider as you think about defining your disaster recovery deployment. The first one is on the primary and DR region separation. The suggestion is to pick a DR region that is far enough from your primary to avoid the same disaster, but close enough for practical network connectivity. And of course, this depends on the applications that you will be running. This is key to avoid a single point of failure. We at Microsoft advise customers running mission critical workloads in the Middle East to leverage multiple availability zones and even multiple regions for backup and failover. This way, even if we have a full regional outage, it would not be taken down and your application could fail over to a safe location. The second one is data sovereignty and compliance. You need to ensure your disaster recovery strategy aligns with data residency regulation. You have seen this over the beginning of the presentation, and you will see this topic coming up over and over. If you operate in sectors with strict data sovereignty, like government, finance, healthcare, you would likely choose a disaster recovery region in the same country or legal jurisdiction as your primary. Of course, if regulation permit, and we're seeing some flexibility on that, you can choose a different country or region for your disaster recovery to get more geographic separation. Some UAE companies use West Europe as an additional failover site beyond the Middle East. But of course, the right choice depends on balancing compliance and risk. After the recent incidents, we see more and more interest from customers in multi-geo disaster recovery. And this means having a tertiary backup outside of the Middle East for extra assurance. Service availability is super important here as well. When selecting a region, we have to consider whether it offers all the services your application needs. So the Middle East region supports all the fundamental services and many advanced ones, but there's a handful of very latest Azure services that might be launching first in other regions like Central, Western Europe, or East US, and come to the Middle East a bit later. If your disaster recovery environment requires a specific service, we can always double check through the Azure Microsoft Global Infrastructure Products by Regions link, which I'll paste in the chat in a second. The second to last point is the network and latency. For your disaster recovery, you'll be replicating data continuously. So network bandwidth and latency matters. Azure's backbone connects Middle East regions with high-speed links, but transferring large volumes, for example, Europe, will introduce more latency. So you need to continuously evaluate your application's tolerance. A financial trading system, as an example, might need near zero data loss and ultra-fast failover, pushing you towards a very close DR site requirement. Whereas, for example, an internal application that might handle a few minutes of lag and could fail over across continents if needed. The last point is on the testing and monitoring. Whichever region you choose, regularly test your failover process. And Azure Site Recovery facilitates these failovers so you don't disrupt production. You can verify that your application can come up in the DR region and users or even customers can connect to it effectively. Additionally, we offer the monitoring watch health option for both your primary and secondary deployment, and this is a good asset to leverage. So with that, Petra and team, I want to conclude by just emphasizing the importance of this topic more than ever. And we have a great partner here with Exquitech, who is very expert in this topic. So we look forward to taking you through the discussion and then hopefully answering some questions towards the end. Exquitech team, back to you.
Thank you, Carlos. My name is Eli, Infrastructure Director at Exquitech. My focus is on leading cloud and enterprise infrastructure strategy across Azure, hybrid environments, and secure network architecture. And I will now walk you through how we design high availability in Azure. So here we are looking at two important Azure concepts that help us design highly available workloads. Availability zones and sets. On the left side, we have availability zones, which provide the highest level of availability in Azure with an SLA of 99.99%. So availability zone distribute virtual machines across separate data centers within the same region. Each zone has its own power, cooling, and networking, which means that even if an entire data center fails, your application can continue running from another zone. On the right side, we have availability sets, which provide 99.95% SLA. Instead of separating workloads across data center, availability set distribute virtual machine across different hardware racks and update domain within the same data center. This protects against hardware failure and planned maintenance event. So in practice, when availability zones are supported in a region, there are usually the recommended option for maximum resilience, while availability sets are used when zones are not available or when workload require a simpler architecture. So now let's look at how Azure Backup helps protect your data across different environments. The Azure Backup Service provides simple, secure, and cost-effective solution to back up your data and recover it from the Microsoft Azure cloud. So what can I back up? I can back up on-premises servers, backup files, folders, system state using the Microsoft Azure Recovery Service agent, or use Azure Backup Server and integrate with on-premises VMs and hypervisors such as VMware, Hyper-V, or any other on-premises workload. So in this case, you can take a full virtual machine backup for your environment, your virtual environment from the VMware by integrating VMware and Hyper-V with Azure, and you take a full virtual machine on Azure. Then second one, we can take Azure VM backup, entire Windows Linux VMs using backup extension or backup file, folders, and system state using the agent, Microsoft agent. Third one, you can back up SQL Server database running on Azure VMs. And we can back up also SAP HANA database running on Azure VM. In addition, Azure Backup helps protect your critical business system and backup data against a ransomware attack by implementing preventive measures and providing tools that protect your organization from every step that attackers take to infiltrate your system and by using retention long-term policy. Now, another very important feature in Azure Backup is immutable backup protection. So which helps protect organization against ransomware and data deletion. With immutable backup, Azure applies special storage policies that lock backup data for a defined retention period. During this time, the backup cannot be modified, overwritten, or deleted even by administrators. This provides an additional layer of protection because many ransomware attacks especially try to delete or encrypt backup data before attacking production systems. So this capability is fully integrated with Azure Backup and the Recovery Service Vault, enabling protection for workloads such as virtual machines, database, and applications. Another important point here is that Azure can also integrate with third-party backup solutions such as Veeam, allowing organizations that already use Veeam or any other third-party backup tool to extend their backup strategy to Azure for offsite backup or disaster recovery purposes. And in this case, if you have, for example, your own backup solution, you can integrate directly with Azure by having Azure Blob Storage. And this Azure Blob Storage is cost effective. So you can take your backup, you can integrate your backup tool directly with Azure Blob Storage. And then the backup will take the first job on the local disk on-prem. For example, if you have it on-prem, the second job will be on Azure. So here you can protect your data against failure on-site or any other issue. So that covers the high availability design and backup in Azure. I will now hand over to Cassandra, who will walk you through the storage redundant and disaster recovery strategy.
Hello everyone, my name is Cassandra Atalla and I'm an Azure Cloud Solution Architect. My role is to help the clients to design and implement cloud strategy. So in these slides, we are going to discuss the Azure storage redundancy options. Azure Storage automatically replicates your data to ensure durability and protect it against failure. However, different workloads require different level of protections, which is why Azure provides several redundancy options. First, we have LRS, locally redundant storage. Think of it as keeping 3 copies of your data in the same data center. It protects you if a disk or server fails, but if the whole data center goes down, well, your data won't be available. So LRS is usually good for development or workloads where cost matters more than uptimes. Next, we have the ZRS, Zone Redundant Storage. Here, Azure spreads the copies across 3 different availability zones in the same regions. So each zone is physically separate. That means if one data center goes offline, your data is still available from another zone. This is great for apps that needs high availability within a region. Then we have the GRS, Geo Redundant Storage. Azure keeps 3 copies in the primary region and replicates them to appear secondary regions. So 6 copies in total. This way, even if an entire region has a disaster, your data is safe. Finally, we have the GeoZone Redundant Storage, gives the highest protection. It combines the zone redundancy of ZRS with the geo replication of GRS. Copies are stored across multiple zones in the primary region and then replicated to another region. This protects against both data center failure and regional outage, ideal for mission-critical workloads. So let's walk through the diagram to understand how Azure protects data using different redundancy models. Starting, we have the locally redundant storage, LRS. In this model, Azure keeps 3 copies of the data within a single data center in one region. So this protects against hardware failure like a disk or server failure, but it does not protect against a full data center outage. Next, we see the zone redundant storage. Here, the data is replicated across 3 different availability zones within the same Azure region. Each zone has its own dependent infrastructure, such as power, cooling, and networking, which increase availability in one data centers if one data center fails. Moving to GRS, in this setup, Azure stores 3 copies of the data in the primary region and replicates another 3 copies to a secondary regions. This means that the data is protected and not only from a data center failure, but also from regional outage. Finally, we see read access geo redundant storage. This option is similar to GRS, but it also allows read access to the secondary region, meaning application can still read data from the backup location if the primary regions become unavailable. So overall, the diagram shows how Azure increases data protection and resilience as we move from local redundancy to zone redundancy and finally to geo redundancy across regions. Common Azure DR architecture. So Azure ASR. So this slide shows how Azure Site Recovery helps protect your environment by replicating it to Azure, assuring business continuity and disaster recovery in case of failure, outage, or disaster. So we have the primary site, which represents the on-premises data center. It includes different tiers such as DB tier, app tier, web tier, and Active Directory. So Azure Site Recovery replicates these workloads from the primary site to Azure. The initial replication will be complete while subsequent replication will only transfer change. So it helps with optimizing the bandwidth usage and minimizing the cost. And for the connection between the on-premises primary site data center and Azure is done through a site-to-site VPN, which provides a secure communication for replication. And finally, on the right side, as we can see, the Azure secondary or recovery site, the replicated data is stored in Azure storage and run in IaaS VM, but these VMs are only started when a failover happens. This means you only pay for storage and memory. You do not pay for a full compute resources unless you need them during a failure or when you need to activate your site. If the primary site goes down, we can trigger a failover, and Azure brings up the replicated virtual machine with a minimum downtime. So now, in this slides, we are looking at the key security and operational practice for building a reliable disaster recovery environment in Azure. So let's start with identity and access management. In any cloud environment, controlling access is essential. With Microsoft Azure Active Directory, organizations manage identity from one central platform. Using role-based access control, ensure users only have the permission they need, and multi-factor authentication, MFA, adds an extra security layer for an important account. Next, we have the network security. When workloads fail over, they run inside an Azure network, so traffic can be controlled using network security group. Additionally, protection can be added with Azure Firewall and Azure DDoS protection to block malicious traffic. For hybrid environments, secure connectivity between on-premises infrastructure and Azure can be done using a VPN or Azure Express route. The third area is data protection. So because disaster recovery involves continuous data replication, protecting data is critical. So Azure secures data with encryption at rest and in transits. So sensitive information like password and certificates can be stored securely in Azure Key Vault. Using immutable backup also helps protect data from ransomware attack, as we have seen in the previous slides with Eli. So next is monitoring and threat detection. Continuous monitoring is important for any DR solution. So with Microsoft Defender for Cloud, organization can detect vulnerability and security threats. Logs and system activity can be analyzed using Azure Monitor and Azure Log Analytics to maintain visibility over the entire environment. Now, let's discuss the high availability and disaster recovery. So workloads can be distributed across availability zone to improve availability. So for backup and recovery, Azure Backups and Azure Site Recovery allows organization to replicate workloads and perform failover quickly. Usually, DR testing is also important to ensure recovery objective can be met. So finally, we have the governance and compliance. Organizations must ensure their cloud environments follows internal policies and regulation. So with Azure policies, administrators can enforce rules across resources. Audits, logs, help tracks activity for compliance. Sorry. In this slide, we're looking at how organizations can optimize cost when implementing backup and disaster recovery in Microsoft Azure. When designing a disaster recovery strategy, it's important to understand what factors influence the overall cost. First, different Azure services have different pricing model and tiers. The cost will depend on the type of service you choose, the performance level required, and the storage option used for your workload. So another important factor is data transfer. So in Azure, inbound data is generally for free, but outbound data, also called egress traffic, may be billed depending on the amount of data transferred and the destination. This is especially relevant when replication occurs between regions. So the Azure region also plays a role in pricing. Different data center location may have different costs. So organization often choose a region based on a balance between cost, compliance requirement, and proximity to their primary environment. So now, if we look especially at disaster recovery, the main costs typically include replication infrastructure, storage used to hold replicated data, network bandwidths for transferring data between regions, and compute resource used during failover or DR testing. So when using Azure Site Recovery, the pricing model is based on a per protected virtual machine replication license. This means that each VM being replicated has a monthly protection cost. In addition to that, there are storage costs for the replicated disk and network bandwidths used during replication. So a key advantage of Azure Site Recovery is that the virtual machine in the recovery environment are not running during normal operation. So organizations mainly pay for the replication service and the storage that holds the replicated data. So if a disaster occurs and a failover is triggered, Azure then starts the virtual machine in the recovery region and compute cost begins only at that moment. So here you use pay as you go methods. As much as you use your VM, you will be charged. This approach allows organizations to maintain a fully prepared disaster recovery environment without paying for constantly running standby infrastructure. So now to see how this works in practice, I'll hand over to my colleague Rebecca Sam'an, who will demonstrate a failover scenario. Rebecca?
Cassandra. Hello, everyone. My name is Rebecca Samhan, and I'm a cloud engineer at Exquitech. Today, I will demonstrate how we can use Azure Site Recovery to protect an Azure virtual machine and ensure business continuity in case of a disaster. In this environment, we have a virtual machine running in UAE North, and we have configured the replication to West Europe. Here, we can see the replication status of the virtual machine. The VM is currently protected, and the replication health is healthy. Azure Site Recovery is synchronizing the data from the primary region to the recovery region. Azure Site Recovery provides two types of failover, test failover and real failover. Test failover is used to validate the disaster recovery setup without impacting the production environment. On the other hand, a real failover is performed during a real disaster. This operation starts a replicated virtual machine in the recovery region and shift the workload to that region. Now, I will perform a failover operation. A failover allows us to start the replicated virtual machine in the secondary region, which in our case in West Europe. This simulates a real disaster scenario where the primary region becomes unavailable and we need to restore services quickly from another region to ensure business continuity. During the failover, Azure Site Recovery will use the latest available recovery point to create and start the virtual machine. This ensures minimal data loss and helps reduce downtime. Now that we have initiated the failover process, it may take few minutes for the operation to complete. During this time, my colleague Eli Tawil will continue with the next part of the demo while the failover is running in the background.
Thank you, Rebecca. Hi, everyone. My name is Eli Tawil. I'm a senior cloud engineer at Exquitech, and today I'll be demonstrating failover from one region to another on SQL servers. As you can see here, we have one SQL server, and it includes one database. The database currently hosted in UAE North region, and it is online. In case we need to fail over to a different region, we must have a failover groups. The failover group will have a server in the standby in the secondary region in North Switzerland, and will use the same connection string. So you don't have to change it manually on your application. And the failover is quite simple. you just have to go to the secondary region and do a failover when you have the primary region down. So once I attempt to create the failover to the secondary region, it will only take a few seconds to complete. And once it's completed, the demo, the primary region becomes a secondary, and the secondary will become a primary region. That you can continue working normally without changing anything. And also you can fail back once the primary region comes back online with the updated data failed back to the primary region. As you can see here, the northern Switzerland is now the primary, and the secondary is UAE, and the failover has completed. Now we will get back to Rebecca to complete the ASR.
Thank you, Elia. Okay, as you can see here, the failover is still running. We'll wait for a few minutes. Okay, now that the failover process has completed, we can see that the virtual machine is successfully running in the recovery region, West Europe. In the same time, the original virtual machine in the primary region, UAE North, is now shut down. This confirms that Azure Site Recovery has successfully redirected the workload to the secondary region, ensuring business continuity even if the primary region becomes unavailable. Once the primary region becomes available again, Azure Site Recovery also allows us to perform failback operation, which means we can move the workload back to the original primary region. That concludes my part of the demo. I will now hand over to my colleague Cassandra.
Sorry. Okay, thank you for your attention, and thank you, Rebecca. So now we've reached the question and answer session. So please feel free to type your question or answer any questions that you want. Okay, Shrikant asked, we are using Microsoft 365 with Dubai region. What is redundancy and business continuity available for us if full UAE region is down? Okay, this is a very good question. So when using Microsoft 365, Microsoft already provides built-in high availability and regional redundancy as part of the service. Even if your tenant is hosted in UAE, Dubai, so your data is automatically replicated to a paired region, which is the United Arab Emirates, so in Abu Dhabi. So this means Microsoft continuously replicates your data between the two regions. So if the primary region become unavailable, Microsoft can automatically switch operation if you want to the paired region. So this failover process is handled by Microsoft, and customers do not need to manually trigger it. So from business continuity perspective, Microsoft services such as Exchange Online, SharePoint, or Microsoft Teams are built with multiple layers of redundancy, including data replication across data center, automatic service failover, and continuous monitoring and recovery. So if an organization wants additional protection against failover, ransomware, or long-term retention, many companies implement third-party backup, such as Veeam backup for Microsoft 365 to store copies outside the Microsoft 365 environment. Another question from Hasib. Okay, asking, suppose our primary site is using a public IP address for a critical sales, logistic, finance application. In case the primary site become unavailable or goes out of coverage, how would Azure Site Recovery handle the public IP during failover? Would we need to manually change the public IP and update it within our application, or would it be automatically updated through the DNS? Okay. So, Hasib, if your application currently use a public IP address on the primary site, Azure Site Recovery no, does not automatically move the same public IP to the disaster recovery environment, because public IP address are tied to the specific location or resource where they were created. So during a failover with Azure Site Recovery, the replicated virtual machine will start in Azure, and it will typically be associated with different Azure public IP address.
Cassandra, one more thing also, to avoid manual changes, we typically use DNS with a low TTL or services like Azure Traffic Manager to automatically redirect the traffic to the DR site. So it's recommended to use, in this case, the DNS.
Okay.
I think there's a few more questions, one from Anand and one from Ahmed as well. Can you see them, Cassandra and Eli?
Yes, we can see it now.
Okay, perfect. I think there might be some sort of time lag, but I think we have
from
you have addressed.
we have a question from Ahmad. What if UAE region completely out of service and my infrastructure as a service in UAE only will be affected, or Microsoft cover redundancy? So if you deploy your infrastructure service resources, VM, disk networking in a single region, such as Microsoft Azure UAE, and the entire region become unavailable, then your infrastructure resources in that region will also become unavailable. So Azure does not automatically move your VM to another region. We need to run the ASR tool to recover this VM from UAE and another region. So Azure provides high availability inside the region using availability zone, as we mentioned in the presentation. But if the entire region goes down, workload hosted only in that region will also be unavailable. To protect against that scenario, we replicate workload to another Azure region using Azure Site Recovery, which allows us to fail over the application to a secondary region.
Okay, there's another question from Anand asking what is the physical protection of the data center in the UAE region? Uh, uh, so Microsoft Data Centers follows a very strict physical security model, Anand. In this way, it facilitates in the UAE the protection with multiple layers such as secured perimeter, 24/7 monitoring, on-site security, and biometric access control. So only authorized staff can enter specific security zone inside the data center. Also, a cloud region is not a single building. The UAE region includes multiple physical separate data center, and data is replicated between the paired region. So UAE North Asia region in Dubai and UAE Central Asia region in Abu Dhabi. So this combination, if you want, of strong physical protection and regional redundancy helps ensuring the business continuity even if a single facility is impacted. Sorry. Okay. If there are any other questions, please feel free to ask.
I think there was a follow-up from Shrikant who is saying if there provision for Microsoft 365 to be available if both Dubai and Abu Dhabi are down. And then I just saw a new one as well coming from Samir and Ahmed on FNO as well.
Okay, answering Samir question, if there any latency application, yes, there's an important consideration when an application fails over from one region to another. For example, let's take an example from UAE to Europe. Users may notice slightly higher latency because data has to travel to a longer distance. So this actual impact depends on the application type. So we have the interactive apps like team or web apps are more sensitive to latency. And we have the batch or background workloads are less affected if you want. And Microsoft provides several ways to measure and mitigate latency. We have the Azure Network Performance Monitor, where we can test connectivity and measure latency between regions. And we have the traffic routing via Azure Front Door or Azure Traffic Manager. So direct user to the nearest, if you want, healthy endpoint automatically. And we have the Content Delivery Network, CDN, for static content, reduce the perceived latency by catching data closer to user. Ahmed Ballouh asked, what about D365 FO? Also shall get affected of the availability. Yes, Dynamics 365 Finance and Operation is a cloud service hosted in Microsoft data center, so it follows the same regional availability and redundancy model as other Microsoft 365. So if your primary region become unavailable, Microsoft can fail over the paired region. Availability may be temporarily affected during a failover, but Microsoft designed the service for minimal downtime. Okay, Samir asked, Does Azure provide online cost calculator for maybe site-to-site backup? Yes, for sure. Microsoft provides the Azure pricing calculator, which is an online tool to estimate cost for almost any Azure service, including site-to-site backup and Azure backup and disaster recovery scenario. Okay, so we've covered today Azure disaster recovery and backup strategy, and I hope you found it useful. If you have any further question, please feel free to reach out.
I think one more from Ahmed here.
Okay, so Ahmed Ballouh is asking, what is your recommendation in current situation for UAE region users? Okay, so given the current situation in the UAE and considering regional risks, my recommendation for UAE region user would be rely on regional redundancy first. So it keep your workloads in UAE North and UAE Central per region. So this ensures a minimum latency and fast failover within the country. For sure, use the Azure Site Recovery or Microsoft 365 built-in replication, for example. But to be on the safe side, use the Azure Site Recovery. Avoid depending on faraway region for latency and for live, because users may notice delay, as we discussed previous. So, and consider additional backup for critical data. Do we have more questions?
There's one more from Hasib saying, can we perform test failovers without affecting production?
Okay. Can we perform test failover without affecting protection? Yes, absolutely. One of the key benefits of Azure Site Recovery is the ability to perform test failover without impacting your production environment. So test failover creates a temporary isolated copy of your VMs in a target region. So it lets the users to verify that applications start correctly, networking works, and data is intact, and production workloads continue running normally. So users are not affected at all. And after testing it, you can clean up the test environment without any change to production.
He's following up by asking how often should disaster recovery testing be performed? And I think there's another one that he has asked: after the primary region is restored, how does failover work? Will data automatically sync back to the primary site? If you
Okay.
want, Hasib, I think you might be able to come off mute as well if it's easier, or I don't know if it's possible.
Okay, to answer Hasib, the first question about performing a test failover, disaster recovery should be performed on a regular and scheduled basis to ensure your plans actually work when needed. So minimum recommendation at least once a year for a full failover testing, and best practice each 3 months quarterly. And for the second question, can we perform test failover without affecting production? Yes. Okay, there's another question. Okay, so thank you all for your time and attention. That concludes our session. Thank you.